Hey everyone, welcome to my channel. Today we're continuing our exploration of vectors. In the previous video, we looked at basic actions with XYZ object. Now we will go through more advanced features. Before getting started, if you find the content useful, please like this video, subscribe to the channel, leave some comments, and turn on notifications. Actually, what I decided to do before getting started with more advanced features is to refactor a bit code and add more features. So if I go to my XYZ extensions class, here I here I added some documentation for it. You already should be familiar with the documentation because we covered this in the selection part. So here visualize method simply visualize the point. Then we have a method called asCurve, and what it does, it visualizes the vector as curve. Again, on our way, we will be using this a lot of times, so don't worry about it. But now you should be like everything was gathered from the previous part, so you should be familiar with this. So what we're doing here is that we're passing the vector. Actually, that is the XYZ object on which we will do some action. And here we have origin that equals by default to null, and here we have double that equals by default to null. And actually here, as you can see, I put a question mark, and that means that because by default you cannot make type values, you cannot make them because we have reference types and we have value types. I hope that you went through this and kind of understood it. It's crucially important to know the difference between reference types and value types. But the main gist of this is that we have double and that cannot equal to null because it's not nullable. And we just make it nullable by putting a question mark. If you wanna learn more about this, just stop a video for a moment and learn about nullable, learn about how we can make our value types nullable. If you're not familiar with value types and reference types, make sure to check it out. And here we're using this cool kind of operators where we can check if that is null. So basically, in the case when origin is null, I'm gonna assign XYZ 0 to this. If length is null, I'm gonna get the length of the vector itself. And here I'm just returning a line that is created by origin. And here we're using a method move along vector. I'm gonna show you this again, but the main idea is that we're creating a line, we get the origin, and we're just getting the last point like from the vector. So you just need to play around with this a bit if you don't kind of get the whole part of this. But from the previous video, it should be clear. What that one does, what that method does, move along vector, is that I have two of them. So basically, I have two overloads, right? Overloads is just a concept of having like a method with the same name but having different arguments that you need to pass here. So here I have move along vector that grabs the vector along which you want to move, and plus you're adding some distance. So here I simply go point to move. I'm passing the vector and I'm just multiplying this. If you remember from the previous video, we checked how this addition works with vectors and how subtraction works with vectors. So if you're not familiar with this, if you're feeling that you're struggling with it, make sure to watch the previous video because what I did here, I just added like a couple of methods as you can see. I think documentation takes more space. The main idea is that I just clean that up, and if you sit down and think about it and go to the previous video, you'll make sure that you get this straight. Now we should get familiar with a very important concept and two actual concepts, two techniques about vectors. And the first one is the cross product, and the second one is the dot product. So first of all, what I want to do is to go to documentation. As you can see, I'm in Revit API docs, I went for Revit 2020, and I can simply look for XYZ object. And here we have a lot of methods actually, and I encourage you to kind of go through them, play around with them. I'm not gonna go through all of them, but actually I'm gonna check out the ones that are really handy and that and the ones that really help me a lot on my way of developing Revit plugins. So the first one is the cross product. That is the first one that I want to look at. So basically what it does is that by having two vectors, you can have the perpendicular one. So let me show you what will actually give you. So let's create two simple vectors. So let's go to main there. Um, I don't want to even use this part for the time being. Let's kind of delete it. Let's name this. And now I don't want to select any elements for the time being. Let's name this first vector. We're just playing around. So I'm gonna have new XYZ. Let's have like on the X, I want to have 0, right? So on the X, I want to have 0. Or let's go maybe 0 point, or let's go 2 on the X, 0.5 on the Y, 0 on Z, and normalize it. So let's have something like that. And now I want to visualize it. So I'm going to go first vector, visualize, or let's go with the S curve actually. I want to go like this. And let's visualize curve. Oh, we don't have, as you can see, we don't have an extension method for visualizing the curve. So let's go to document, actually, it's time for us to create a new class. I'm gonna uh, click Control Shift A. That is the shortcut for creating a new item. So what we're gonna do is that I'm gonna pass here the extensions, curve extensions, and again, keep in mind the syntax. You need to make a class static. And here, because now we're gonna have like extension methods, so we're gonna add functionality to the methods that we have in Revit API, but we don't have access to them. So, but we wanna kind of uh, extend new methods, create new methods, right? So public static, what I want to return, actually in this case, I want to return void, and I'm simply going to name this visualize. And I'm going to say this action should be done on curve. As you can see, ReSharper helps me, and that tells me that, you know what, that curve is located in Autodesk Revit DB namespace. Do you want to kind of load it? Do you want to use it here? And I'm telling yes. Curve. And actually that's it. I just need to also pass a document there. And let's maybe be more like I like to not use all of the shortcuts because it's better to be descriptive. So what I'm going to do is that I'm going to go document, create direct shape, if you remember from the previous part. And we're going to create a list of objects and we simply pass the curve in there. And what it does, it passes this one. You can also document it like this. Method is used to create to visualize curves in a Revit document. Also, you can add like documentation for the name of this. Now we're just learning that. And now, as you can see, we have this method, so we can simply visualize it. And actually, I think I would like to rename this ones as well like that. So I don't want to have these shortcuts. Okay, let's even not do this. I'm gonna show you a trick where you have like these when you want to change these ones and change these ones simultaneously. So I'm gonna click Control and double R, and now I can say UI application, and I will have the change everywhere. The same for this, but I think I have only there here. UI document. And here I'm gonna have document. There we go. As you can see, everything. I made the change to everywhere that it was before. So now I think it's good time for us to just visualize the vector itself. So let's go to an empty Revit project. And what I want to do here is that at least let's kind of go to visibility graphics. It's somewhere here. And let's kind of go to side and see this internal origin so we can see like where it is. Let's gonna have some like reference planes to visualize it like that. That can be quite cool. Now I'm clicking AM, and here we have this core Revit module, and we can simply run this. As you can see, that is the vector that I've created. So we visualize this. Let's grab some of the basis vectors. And what is a basis vector? So Revit, if I go back to Revit and I go to 3D, and let's turn on the visibility also for the internal origin. As you can see here, we have these kind of gizmo that is like, you can think of these as vectors actually. That represents the global coordinate system. We will talk about coordinate systems and all of that stuff. But for the time being, what you need to understand that we have these three main vectors that are immutable. They cannot be changed. So they're always having the same position. So X is marked with red color, green is marked for, and Y is marked with green color, and the Z coordinate is marked with the blue color. And if you go there and use XYZ, you have them as static properties, right? So you can actually get these pretty easily. So as you can see, you can go like 0 and get also like the basis one. Let's get the basis of the vector Z, and I'm going to go as curve, and I'm going to visualize it. So now I want to visualize two vectors. Let's kind of see what that will do for us. As you can see, what we have here is that we have one vector. If I go from the top, as you can see, it simply goes there. And we have this second vector that goes up, right? As you can see, it simply goes up. And what we can do with the cross product is we can get the perpendicular vector to both of these vectors. So now we can get the perpendicular. So let me show you what we will do right now is that I'm gonna go with the simply, let's have first vector, let's have the basis z vector, xyz basis z vector, and I'm gonna have var perpendicular vector. And what I'm gonna do is that I'm gonna go first vector cross product to the basis z. And here, I'm going to go perpendicular vector as curve visualize document. So let's see what we have here. So now, when I run it, oops, it's not that, this one. As you can see, what happened is that we actually got the perpendicular one. So basically, we had this one, and that is the basis vector that goes up. We've got this one, which actually points here, as you can see from plan. And now we've got the one that is perpendicular to both of those. So if you measure the degree between two of those, right, angular, you'll get the 90 degree. And if I go to 3D, and you would measure the distance, the angle between these two vectors, you would also get a 90 degree. So basically, that is what a cross product is. And actually, you may be a bit confused about, but where we can apply this. And actually, to be honest, it's just crucial for you to keep that in mind because it will come, it will come in handy really soon if you're like on your way of developing Revit plugins because each Revit element has some information about it, some geometrical information like about vectors, about a lot of stuff. I don't want to touch them. I don't want to now go through them. We will talk about them later on because we actually need to be familiar with the concept of transform. And it's going to be dedicated to another video. Now just play around with vectors. Just understand what is a cross product and what is like and other kind of actions. You really need to be confident with moving points along a given vector. You need to be confident with all of these operations like adding vectors, subtracting vectors, dividing vectors, multiplying vectors. Now you're familiar with cross product, and now I want to go to the dot product because to be honest, cross product is pretty easy for us because we can visualize it because by having, as you can see, by having two vectors, we, by having actually two vectors, we get another vector. So by having two vectors, we get the third one. But if we go to the dot product, we're getting the double. And like in this particular case, the double is not so easy to visualize. So what we want to do is that, first of all, whenever you work with geometry, always try to visualize it. Try to do this in Revit. I always kind of recommend you to kind of manage to visualize pretty much any geometry in Revit so you can actually be sure and you can um, kind of make sure that you're not making a mistake, so that can be quite helpful. And what I did is that I Googled and I found this cool application, like some website. You can actually check it out here. And that actually represents the what a dot product is. You can Google it, you can watch some YouTube videos about what it is, and there are a lot of great explanation about it. But I really found this kind of visualization really helpful. So what we can do here is that we can have here two vectors and kind of see what a dot product is. So a dot product in this particular scenario is visualized by this yellow line. So this yellow line is actually the distance that you get. So here you have one vector, here we have another one, and if you get dot product between two of these vectors, you will get this distance. And if you think about this, it's just about uh, having a perpendicular relationship between them, right? So it's like we're having this perpendicular relationship and we're getting this distance. We can also kind of calculate this via trigonometry if you want, but why care about trigonometry in this particular case when Revit developers already did that for us and we can simply use dot product? So now the main question is that when that can be useful. So, and I found two main applicable scenarios where you can use it right off the bat. So the first one is how we can find relationships between vectors. What you will usually do is that you will have two vectors and you would want to understand whether they're pointing to the same direction or they're opposite or they have 90-degree relationship or or any kind of relationship, but that is kind of like the first usage for this. So let me show you how we can do this. So let me simply create two vectors and let's go like let's create another one here on the plan. I just showed you the cross product. Now I actually don't need it for the time being. So I'm gonna have some kind of, I'm gonna click Control D, that will copy the line. I'm gonna name this second vector and let's create for this, mm, let's just kind of go and have maybe let's play around with actually basic ones. I'm gonna go XYZ basis Y. So first of all, let's visualize both of them so we can understand um, what vectors we are dealing with. So I'm gonna run this and we're gonna see what vectors we have. Actually, maybe let's make this kind of smaller so it's not on our way actually like this, right? So here we have two vectors, and I want to get some relationship between them. The first thing when you get a relationship between vectors by using a dot product, make sure that you have them normalized. And keep in mind that a normalized vector, it's a vector which length equals to 1. So keep that in mind. So now I want to get some relationship between them. So let's say I want to find out whether like let's start with this with simple techniques. Let's try to find out whether vectors are equal, right? So I'm gonna even delete those and we're gonna change the vectors we're dealing with. So here I'm gonna go to vectors that I'm comparing and I'm gonna create the actually the same one. So as you can see, we have two vectors that are completely the same. And let's use the task dialog uh, class, and that actually just will have will kind of prompt us with a window, and that will show us some instructions that we show. Just to have this in Revit, just to visualize. And I'm going to go first vector dot product, and here I'm going to have with the second vector, and I'm going to use toString method because this method show waits for the string here. We can actually go and make it here. We can go like that, copy this. Let's cut there. Let's go var dot product. I'm gonna paste it there and I'm gonna type it here. Let's kind of visualize it. Oops. Let's kind of see what it will give us. So now when I run it, let's go here. I'm gonna run it. There we go, we have one. So basically now when we have two vectors that are completely the same, now as you can see, we have two vectors that are completely the same, it gives us one. What if I have like a minus here, right? So what if the vector is pointing to the different direction compared to the previous one? So now -1. As you can see, this vector is pointing here, this vector is pointing here, so that gives -1. Okay, let's go to the perpendicular ones. Let's go and put this to the x. And now let's kind of place it right here. And that will be 0. So one is pointing here, one is pointing here. So what is the takeaway? That we have two vectors, and by using dot product, we can actually get their relationship, whether they're perpendicular, whether they share the same direction, or they're opposite. And again, why is that? Because if I go back to this program, what we have is that we have one vector here that is pointing here, one vector that is pointing here, and as you can see, they're perpendicular. Again, the yellow line representing this distance, and as you can see, it's 0, right? If you move it here, right, it's gonna be here. It's gonna be this distance, so it's gonna be 1. The same goes here again, right? So now here we can play around and actually understand why that happens, right? Also, you can play around and see what kind of values it gives you when it's on the right side or it's on the left side. For example, let's actually use another vector, like let's go new, XYZ, and I'm gonna put like 2 on the X, 0.5 on Y, 0 here, and I'm gonna go with the normalize, right? So let's see what kind of value it will give me right now. So now I can easily delete this, and now let's run this again. 0.24. But what really is important here, what is really crucial here is that check out the sign that it gives you. So now it's a positive sign. So here, when this one is like within this place, it will give us the positive sign. So if my vector is pointing here or here or here or here, it will give me a positive sign, right? Let's put a minus to our x, so that will be here, and check out what kind of a sign it will give me as well. So here I'm going to go to the x and make it with a negative sign. Let's kind of have it here, main, check it out. It also gives us with the positive value, as you can see. So what does that tell you is that basically when you have a vector and another vector is located within this portion, right? If that looks, let me kind of draw even some lines. So if vectors are going like that, they're gonna be all with positive sign, right? So they're gonna be all with positive sign. So that's the way for you to differentiate them. Let's kind of negate the vector right now. So here I can use negate, and that will kind of give me the vector the opposite to the one that I have right now. So I'm gonna run this again, and that gives me the negative sign. And now that's pointing here. As you can see, right now when the vector is pointing somewhere here, right, like this, it's going to give me a negative sign. When it's pointing here, it's going to give me a positive sign. So that can be quite helpful. Imagine like where sometimes that can be the case, sometimes not. So for example, imagine a rectangle that's kind of representing a room. Let's say that that is a room, and here you have some doors, and the doors will have their facing orientation, meaning we know where they look at, right? Like this. And we know that our room location can be anywhere here inside this room, so that it can be here or here or here. So let's mark this with this one. So we can actually, for example, when you have something like this, imagine that here you have the maybe like the location of your door. For example, you have the location of your door, and you can create vector from here to here and compare it with this one, right? So you can have two of those vectors like that. You can have this vector and this vector, but your door can face inside your room or it can face here outside the room. And by comparing the vector, you can actually check if the sign is positive, for example, it looks inside. If the sign is negative, it looks outside. We will look at where we will come to the developing of a plugin, because right now my goal is to show you what you need to know actually when you get started with this, because that can be kind of really helpful. But keep that in mind that it can really help you a lot. So what is the first takeaway of the usage of our dot product? Is that the first part is usage for getting the relationship between dot product between vectors. So by using a dot product, you can understand whether a whether vectors share the same direction or they're opposite or they have 90-degree relationship or the one located within one portion, like that we checked out when we have one vector, and all vectors that are going within this space, like the ones that are facing here, will actually be with a positive sign, and the ones that are facing to that side will be with the negative one. So it's all about a relationship. And if you want to have some sort of like a homework, create your own method where you will actually have a method, for example, get relationship to or compare with, right? So where a method that will compare two vectors, and as a result, that will give you maybe some enumeration like vector relationship, like perpendicular, parallel, or like perpendicular, like the same direction, the opposite direction, or an undefined, for example. So what we just checked out, make sure that you kind of solidify it with practicing. So create your own method that will actually determine the relationship between two vectors. And what is the second usage? A lot of times, and actually we use this in Revit a lot. So imagine when you have like two of these lines, two lines that are like that. Usually it can be represented as Revit elements. Now we don't care about this. And imagine we have the end points of these lines, these points, right? Sometimes we want to measure them this way. Let's gonna scale it down a bit. Sometimes we can measure them by just their points. Oops. But sometimes we can measure them like that, and that is actually a different kind of um, a different like value, right? So it's a different value. And that is something that, to be honest, I use all the time, right? It actually helps me in a lot of different scenarios, but that is something that will be really handy and really crucial for you to solve some problems related to vectors. So the second problem that dot product solves is that it gives us an ability to measure the distance from one point to another uh, by specifying along which vector we should measure, right? So sometimes we don't want to get like the raw distance, like the distance between 2 points, but we want to say, you know what, don't measure like this, measure along this vector, or you can say measure along this vector. Oops, we need to actually, yeah, to grab this correctly, let's gonna draw a reference plane here or measure like this, right? So we can do this, right? Because, and actually why it's quite handy, think of the family that you are creating, right? Why we can actually use a lot of formulas in there, because we can easily draw a lot of like reference planes and measure them as we wanted to. So if you ever like created a family with rotations and used some trigonometry, you're going to be quite familiar with this. If not, don't worry, we will go through everything. So I'm going to show you how that works. And let's kind of think about how that can be done with this cool app, right? So basically, let's kind of think of that I have a point here. Let's say I have a point here and I have a point here, right? So let's think about this. I have a point here and here, and I want to measure the distance between 2 points along this vector. Let's kind of create a vector between two of those points. And actually right now you can see the result, right? So basically here we have the vector between 2 points, and here we can say along which vector that should be measured by, and the yellow line actually, that is actually what we need. That is actually the distance. Let's go to Revit and kind of like play around with this. I just want to show you how that works and how helpful that can be. So let's go here and create two lines. So now I don't worry about the vectors itself. I'm just gonna have like let's go there and say from point. I'm gonna go with the 2 point, and let's have here, I don't want to have like let's go 2 here, maybe like 3 here. Let's even have like 1 there. Now on the X I'm gonna have 3. Now on the X I'm gonna have 3. Let's on the Y have 0.5. That is okay. These parts I'm clicking Control L to kind of remove them. Now actually I don't worry about this stuff, and this one can be kind of just commented out. I comment this by clicking Control key S. Let's kind of visualize two of this. So from point, visualize document, and 2 point, 2 point visualize. Let's kind of visualize them. So we can see what we actually want to kind of measure. So let's go here and see 2 points. Oh, where are they? Oh, that is that is, oh, okay, let's leave this as that. Okay, so here we have 2 points, right? So here we have two of those points. So as we saw from like from this app that we can create a vector that goes like this, right? So like that, and then we can say along which vector we want to measure by, and our result, our dot product will be when we draw like a perpendicular there, and that will be actually this distance. And that is actually what it is, right? So that is, this portion is actually this distance that we need, right? So let's kind of do this. So first of all, what I want to do is that create this vector. So I'm gonna have like vector between points, and I'm gonna name this from point, and I've created, oh, we don't have it actually. So let's kind of create like how we create vector when we have just 2 points. We simply need to go to what point you want to create a vector, right? You go to point minus from point, and there you go. There you go. You have your vector. Actually, if I just visualize this, so if I go here vector between 2 points, and I go as curve, and I simply visualize it, oops, as curve, visualize it like that, let's kind of see what it will give us. There we go. It was built succeeded. There we go. We have this vector. Again, if you want to kind of move it there, it's okay. Just always keep in mind the characteristics of your vector. The main characteristics of it is that it has the end point, because the start point is always kind of, it goes from the origin of the global coordinate system. It always starts from here, right? And it has the length. And it's kind of really easy to understand because it has the endpoint and the start point is here, like that is going to be the length of it. So now what we're left to do is that we simply need to tell along which vector we want to measure by. So we're going to say var, like var vector to measure by, and we're going to say, for example, xyz base is x. And now if I go var and I say distance, right? Distance along x, I can say, I simply go vector between 2 points, dot product, vector to measure by. And now I want to go with the test dialog, show message. I don't care right now for this. I just want to visualize this. Like distance along x to string. Keep in mind that it gives me the values in fits, I think. Yeah, in fit, right? So keep that in mind, right? But let's kind of, yeah, keep that in mind because it kind of gives me the value in feed. But I'm gonna actually visualize this to you that works. So now let's kind of check it out. I'm gonna delete it and kind of have it there. So it's gonna be 2. So we have the distance too. Let's kind of check out if that works. I'm gonna have this one, and I'm gonna copy this, and I'm gonna copy this to uh, 2 feet. There we go. It's exactly where it is. So that is the correct distance, right? As you can see, we simply did it. Right now, what we can do is that we can say, you know what? I want to create it by for example, I decided I changed my mind and now I want to measure them by the y vector, right? By the y vector, by the basis y. So now I simply create this, go with main, minus 2.5, and that is the reason actually why we need to use math absolute to always have the positive value here. But if I go here, right, and I copy this to 2.5, 2.5, I think like this. Yeah, there we go. Right there we have it. So that is the distance. As you can see, now we can work with these and do a lot of cool formulas as if we were like in a Revit family and do all of these calculations out there. So isn't that cool? So we can actually work with this and like really leverage the power of this. Uh, so right now, I hope that is a little bit clearer for you if you haven't played around with vectors before. Again, and even here, what is really important here to understand is that the fact that this vector is not normalized is crucially important, because if you normalize it right now, let's kind of see what will happen here. So if I normalize it, right, if I normalize it, it's going to give me an incorrect value, because actually, because I'm visualizing, and you may see that that is not the distance that we want to go with right now, right? It's not actually this distance. So it's not actually vector from, we kind of got the vector from here to here, but then we normalized it and changed the distance. And if you want to see how that works in that representation, so that is your vector, right, between 2 points, and that is the vector that you measure by. And if you change this vector, its length, as you can see, it grows, the distance grows. So in this particular scenario, that is crucially important uh, that you don't normalize it. So now it's time for you actually to play around with this and to have a look at it, to kind of just practice. But I want to kind of have uh, you will have some assignments, like first of all you need to create a method that will get the relationship between two vectors. Now you can stop the video and create a method that will create a vector from one point to another, and also you can create a method that will give you the distance along to from one point to another along a given vector. I'm gonna kind of have it there. So let's kind of create, and as you can see here, I have a very similar method for the XYZ, but now I'm gonna create it myself. So public static, and now I just wanna uh, return like XYZ, and I want to say to vector, and I'm gonna go this XYZ, like from um, let's name this from point, because we're actually thinking of this as from point to point. And actually, if you really have small methods, it's not necessary to open these brackets and do that here. You can actually use expression body members. So you can simply put a sign like that and say, I want to go to point minus from point, right? And that will give you something like that. Also, I can copy this, right? And create a similar method, but I'm going to name this to normalized vector. And what I need to do here is that I just need to put this in parentheses and normalize it. There we go. Now we have two cool methods, extension methods. Also, we can say public static double to to actually we can use, I really like sometimes to use like how they use their like Revit developers. So here they can measure the distance from point to point, and they name that as distance to, and we can say distance to along vector, right? Let's be kind of similar. Distance to along vector, right? And we can have this XYZ. So that will be actually from point. Then we will have XYZ to point, and then we'll have XYZ, and that will be vector to measure by, right? There we go. So we have from point to point, and yeah. And we simply need to return math absolute. So this is what I told you, because sometimes it can give you a negative value. And here we're going to go math absolute, and we're going to go from point, and we're going to now use our extension method to vector to this to point. And from this part, I can say dot product vector to measure by. And that is as simple as that. Now, later on in my app, for example, in my applications, I don't need to have all of these stuff, right? I don't need to have them actually. What I can do there is that These ones can be easily kind of copied out. I have from point to point. Let's have like var vector that we want to measure by. Let's say we want to measure by the x. Let's kind of also visualize that vector. But now I can simply say distance, var distance, and I can say from point to distance to a long vector, and I can say 2 point, and I can say that is the vector that I want to measure by. And let's have the distance here. So again, we created now our own extension methods that we can utilize later on in our development. And we simply go distance to a long vector, and we can use it right now. So if I go here, I delete it. Now I call this. We have again this 2 value. We have these 2, and here the value is 2. If I go back and I decide and I change my mind and I kind of said that now I want to use the y vector like that, right? So now I can actually use it like that, 2.2.5. As you can see how easy it is and how extensible it is right now. So that is kind of quite important for you to get a grasp of vectors, get a grasp of cross products and dot products. So to kind of to sum it up, vectors are crucially important for your development, especially when you're working with geometry. But believe me, you're going to work with geometry a lot. Cross product gives you an ability to get the perpendicular vector between two vectors, and dot product gives you a lot of actual abilities, but I would stress on two of them. The first one is to get the relationship between vectors. So whether vectors are perpendicular, whether they share the same direction or they're opposite, and we can also measure distance between points along a given vector. And actually, this can be applicable even so later on when you would want to project a point on a plane, you would also use this technique with measuring the distance along uh, between 2 points along a given vector. So keep that in mind. There are a lot of applications. There are a lot of applications for this. So make sure to kind of play around with this. I hope that now it is clear for you. So I think that's it for this lesson. I hope you liked it. And if you find the content useful, please like this video, subscribe to the channel, leave some comments, turn on notifications, and have a nice day.